Hey everyone, welcome back. Today we're going deep
Yeah.
on collision.
Collisions, yeah.
And no, we're not talking fender benders.
Well, we could, but
We're going way beyond that with a super cool interactive simulation.
it's called collision carts.
Collision carts, yeah.
And we've got some research to back it up.
So we're going to see what happens when things, bump or bounce.
It's a really neat way to learn about the physics behind it all.
Right. It's hands-on.
And we'll tie it all back to the theory.
Like having a digital physics lab, you can actually experiment.
Exactly. Imagine two carts.
Two carts on a frictionless track.
You get to adjust the masses.
Set their speeds.
Then boom.
Collision.
But here's the thing. It's not just about watching the crash.
Right. You actually get to see the forces at play.
The momentum, the energy, how it all changes.
And I think that's what makes this so cool. It helps us visualize some pretty fundamental physics concepts.
Like momentum. A lot of people think it's just about speed.
Yeah, the faster something's going, the more momentum it has. That's part of it, sure.
Yeah.
But it's also about mass.
Okay, so a tiny bullet and a giant truck.
Could have the same momentum.
Whoa, really?
Think about it. A small object moving super fast.
Versus a massive object moving slowly.
It's the combined effect of mass and velocity.
So it's not just how fast you're going, it's how much stuff you've got moving.
Exactly. It's all about the product of mass and velocity.
There's a formula, isn't there?
There is. PMV,
P is momentum.
M is mass,
Yeah.
and V is velocity. Simple, but powerful.
Okay, I'm starting to see how those pieces fit together. But what happens to all that momentum when things collide?
That's where the law of conservation of momentum comes in.
Oh, this sounds important.
It is. It says that the total momentum before a collision.
Has to equal the total momentum after.
Right. But there's a catch.
What's that?
This only holds true in a closed system.
So no external forces messing things up.
Think of it as a cosmic balancing act. Momentum can be transferred between objects during a collision.
Yeah, I get that. Like if one cart hits another, the second one starts moving.
Exactly. But the total momentum of the system remains constant. It's not created or destroyed.
Even if they're bouncing off in different directions.
Exactly. It's a fundamental principle. Of course, in the real world, there's friction, air resistance,
Right. Things get a bit messier.
but the basic principle still applies.
This makes me think of billiard balls. You know when you see those slow-mo videos of them colliding?
Perfect example, that smooth transfer of momentum.
They seem to just bounce off each other perfectly.
And that's what we call an elastic collision.
Elastic.
Yeah. So not only is momentum conserved,
But so is kinetic energy.
the energy of motion.
Yeah.
The billiard balls bounce off with almost the same speed and energy they had before.
Okay, so it's very bouncy, energetic. But what about when things don't bounce back so perfectly?
You're thinking of inelastic collisions,
Oh, yeah, like a car crash.
where there's
Yeah.
a lot of damage and things don't just spring back into shape. In those cases, momentum is still conserved. Remember, that's the law. But some of that kinetic energy is lost.
So it's not as bouncy?
Not at all. Think about the crumpling of metal in a car crash.
Yeah.
That deformation absorbs energy.
Turns it into heat or sound.
Right.
So that's why they don't just bounce off each other like billiard balls.
Exactly. The energy is being transformed into other forms.
Okay, I'm seeing the difference. Now, how does our simulation collision carts show these different types of collisions?
That's what's so great about it. You can actually choose between elastic and inelastic collisions.
So I could set it up so the carts bounce perfectly like billiard balls.
You got it.
Or I could simulate a crash where they stick together, losing some energy.
Exactly. You can experiment with all sorts of scenarios and see how the momentum and kinetic energy change.
It's visual, it's interactive.
A really cool way to grasp these concepts, especially energy transformation, which can be tricky to understand just from a textbook.
I totally get that. Being able to visualize it makes all the difference. It's not just theoretical, it's right there in front of you.
And this brings us to the research paper.
The one about productive experiential learning.
That's the one. It highlights just how valuable these simulations are for learning physics. It's not just about passively reading about concepts.
It's about getting hands-on,
Experimenting, observing outcomes.
learning by doing, right?
Right. And that hands-on experience really helps us internalize these abstract ideas.
It's way more fun, too. I know the simulation was designed for junior college physics, but it seems like anyone who's curious could jump in and have fun with it.
Absolutely. It's super user-friendly. And there are tons of additional resources, worksheets, lesson plans, even links to other simulations and videos.
It's amazing how accessible open educational resources have become.
It really is.
It's like physics exploration for everyone.
Exactly. And speaking of other resources, You mentioned videos and even a car crash game.
Oh, yeah.
How do those fit in?
Well, I think it's important to recognize that everyone learns differently. Some people connect best with visuals, others with interactive experiences, and some might even learn best through gaming.
You're right. There are so many different ways to learn and understand complex topics like physics.
Exactly.
The more diverse the approaches, the better.
It's about finding those sparks of inspiration.
And making those concepts stick.
So instead of limiting ourselves to just textbooks and lectures,
We can tap into these different learning styles, make physics engaging for everyone.
it's about finding the right tools to make those aha moments happen.
Couldn't have said it better myself, meeting people where they are, yeah.
Right where they are. So for our listeners out there, virtually crashing those carts in the simulation,
Playing around with momentum.
what would you say is the biggest takeaway so far? What have we really learned about momentum?
Well, I think it boils down to this. Momentum is this fundamental concept that governs how objects in motion interact.
It's not just some theory, right?
It's happening all around us all the time,
Yeah.
shaping the way things move.
So whether we're talking about, like, a baseball after it's been hit,
Or the impact of a car crash.
momentum is there, dictating the outcome.
Absolutely. And, when you understand the law of conservation of momentum.
That whole total momentum before equals total momentum after thing.
Exactly. It kind of makes you appreciate the elegance of the universe,
Mhm.
the predictability.
Even in those chaotic events, it's like there's this underlying order to things.
There really is.
We were talking about real-world applications earlier.
Right.
The research paper mentioned momentum being super important for designing safety features in vehicles.
It's true.
Can you talk more about that, like how it actually works?
Sure. You know how cars have crumple zones?
Yeah,
They're designed that way for a reason.
to crumple in a crash.
It's about controlling the impact force.
I'm guessing this has something to do with momentum?
It does. By allowing the car to crumple, the impact force is spread out over a longer time.
Instead of coming to a sudden stop.
Exactly. It creates a more gradual deceleration.
So it lessens the severity of the impact.
Right. It's a way to absorb and dissipate the energy of the crash.
Protect the people inside.
Now, another great example is airbags. They inflate so rapidly upon impact, providing a cushion.
I've always wondered how airbags work.
They're basically increasing the time over which the passenger's momentum changes.
So they slow down more gradually.
Exactly. Both crumple zones and airbags are kind of manipulating time.
To reduce the force of impact?
Exactly. It's amazing how understanding a concept like momentum.
Can lead to those kinds of innovations.
It really is. And it's not just cars. Think about helmets.
For football, cycling.
They use similar principles to protect the head.
From those sudden changes in momentum.
Exactly. Even the way a baseball player catches a fastball.
Moving their hand back as they catch it.
They're instinctively increasing the time of impact.
To reduce the sting.
It all comes back to momentum.
Spreading that force out over a longer period. It seems like this idea of manipulating time is like a key factor in a lot of safety stuff. Are there any examples where momentum matters even without a direct collision?
Oh, absolutely. Lots of them. Take rockets launching into space.
Okay, I'm curious, how does momentum work there?
Well, think about what's happening. As a rocket expels hot gases downward,
Yeah,
it's basically pushing against those gases.
right.
And that creates an equal and opposite reaction.
Propelling the rocket upward.
You got it.
So the downward momentum of the gas.
It creates upward momentum for the rocket. It's this continuous exchange.
Rather than one single impact.
You got it. And you see this principle at work in a lot of places. Jet engines. Even walking.
We use momentum to walk.
Think about it. When you push against the ground,
Oh, okay.
you're imparting momentum to the ground. And the equal and opposite reaction.
Propels us forward.
It's all connected.
Wow, I never thought about it that way. So this one concept, momentum, is behind so many different things, from rocket launches to how we move our bodies.
And that's what makes physics so cool, right? These fundamental laws are everywhere, working in all these unexpected ways.
Speaking of unexpected, we were talking about all those different approaches to understanding physics.
The videos, the games.
What are your thoughts on that car crash game? As a learning tool, I mean.
I'm really starting to see the potential.
Yeah.
Initially I thought car crashes, games. Seems a bit counterintuitive,
It's a serious topic.
but I'm coming around. There's a lot we can learn from games,
Yeah.
especially when it comes to stuff like physics with all those cause and effect relationships.
So instead of shying away from the fun factor,
Embrace it.
games can actually help us understand.
Exactly. In a game, you face challenges, you make decisions, and then you see the consequences.
Right there in real time.
It's a really powerful way to learn, especially with concepts like momentum and collisions.
So like a virtual lab where you can experiment safely.
Exactly. No real-world consequences.
That makes sense. It would be appealing to people who find traditional learning, a bit boring.
Let's face it, textbooks aren't always the most exciting.
But don't forget about motivation and engagement. When learning is actually fun
People are way more likely to stick with it.
and actually learn something,
So instead of seeing games as a distraction,
they can be a tool
a way to make learning come alive.
to create those aha moments.
Absolutely. It's about finding what works for each person, using different approaches to really make learning click.
Well said. We've been going pretty deep on this topic. I'm sure our listeners have thoughts bubbling up by now. What about you? What stood out to you as we've been talking about momentum, collisions, even those car crash games?
Anything click.
Any new questions?
Mhm.
Or maybe you're thinking about real-world examples.
Like, how does this stuff actually play out in our daily lives?
Exactly. How does understanding momentum change how we think about the design of things?
The safety features we depend on.
Or even how our own bodies move. It's pretty fascinating.
Physics isn't just about those equations in a textbook.
Think about those core principles, the stuff that shapes the world around us. And what's cool is, with this collision carts simulation,
And we've seen how these concepts can really come alive, even the tricky ones.
they become clear, engaging.
And that's what's so exciting.
Anyone can grasp these ideas.
All it takes is the right tools and a little curiosity.
Absolutely. Well, as we wrap up our deep dive on collisions, here's a final thought. We've been focusing a lot on those direct impacts, but momentum is so much bigger than that.
It's everywhere. Think about it.
Sports equipment, how it's designed,
How vehicles are built to protect us.
even rocket launches, how they harness momentum to get into space. It's mind-blowing when you start to see those connections.
How does understanding momentum impact these technologies, these innovations?
How does it shape our world? It's something to really think about.
We hope this deep dive has sparked your curiosity.
And giving you a fresh perspective on the physics that's happening all around us.
In every motion, every interaction, every single collision.
Keep exploring, keep questioning, and never lose that passion for learning. Until next time.
Happy physicsing.